Hello all, welcome to mathematics paper discussion of part test 15. Let's begin. Question number 1. Alpha beta roots of this quadratic equation. So equation is x square minus 2x plus 4 equals to 0, for which roots are alpha and beta. So let's apply formula for this. Minus b is 2, minus of minus 2. 2 plus or minus root over b square minus 4 into 4, 16 divided by 2 into 1, 2. So 2 plus or minus root over minus 12 divided by 2. 2 plus or minus. So minus 12 can be written as 4 into minus 3. So 2 root minus 3 can be written as root 3 I divided by 2. So take 2 common. You get 1 plus or minus root 3 I by 2. So by 2 I'm writing separately. So one root will be 2 into 1 by 2 plus root 3I by 2. Another root is 2 into 1 by 2. Take minus sign now. Minus root 3I by 2 it is. Okay. So we know cubed roots of unity where omega is minus 1 by 2 plus root 3I by 2. And omega square is minus 1 by 2 minus root 3I by 2. Now, in the same way, if you consider this as alpha, let's consider this as beta. So here alpha can be written as minus 2 times minus 1 by 2 minus root 3 I by 2. So which is nothing but minus 2 into this entire value can be written as omega square. So one root is minus 2 omega square. In the same way, beta, which is 2 into, so here minus should be for 1 by 2, right? So this can be written as minus 2 times minus 1 by 2 plus root 3 I by 2. Just take minus common here. Okay. So now minus 2 into this entire value can be written as omega. So another root is minus 2 omega. So we got alpha value, beta value. So now we need to find alpha power 5 plus beta power 5. So let's substitute in this alpha and beta values. Alpha is minus 2 omega square whole power 5 plus beta is minus 2 omega whole power 5. So we can take minus 2 power 5 common. So omega square whole power 5 is omega power 10, omega power 5 here. So minus 2 power 5, omega power 10. 10 is nothing but 3n plus 1 multiple. So which is omega power 5. 5 is 3n plus 2 multiple. This can be written as omega square. We know 1 plus omega square is 0. So from this result, omega plus omega square can be written as minus 1. Replace here minus 1. So minus 2 power 5 into minus 1, which is 32. So option B is correct. Let's discuss question number 2. So in the question, they're asking us to find conjugate complex number of this. So don't forget they're asking it is conjugate. So let's simplify this division of complex numbers. So given number is 2 minus I by 1 minus 2I whole square. So 2 minus I by expand denominator a square, which is 1 square, plus b square, which is 4I square, minus 2ab. So minus 2 into 1 into 2I, which is 4I. So 2 minus I divided by, So I square is minus 1. So 1 minus 4 minus 3. Minus 3 minus 4 it is. So division of complex numbers. So divide and multiply with conjugate of denominator. So conjugate of denominator is minus 3 plus 4i by minus 3 plus 4i. So denominator is a minus b into a plus b form. So we can write as a square minus b square, which is minus 3 whole square minus 4i whole square, which is 16i square. So in numerator we got 2 minus I into minus 3 plus 4i. Let's multiply these two brackets. 2 into minus 3 minus 6. 2 into plus 4i plus 8i minus into minus. Next multiply with I this entire bracket, which is plus 3i minus 4 into I, which is I square. So minus 6 plus 11i. I square is minus 1, you'll get plus 4 here. The denominator 9. I square is minus 1, 9 plus 6 it is. So minus 6 plus 4 it is minus 2. So minus 2 plus 11i by 25. This is the final complex number. But we need to find conjugate of this. So its conjugate will be our final answer. What is conjugate of this? Which is minus 2 minus 11i divided by 25 it is. Minus 2 minus 11. So option B it is. Let's begin question number 3. So alpha beta roots of this quadratic equation. So given equation is x square minus px plus q equals to 0. So for this equation roots are alpha and beta. Then the equation whose roots are alpha beta. Okay. So ultimately we need to find alpha plus beta and alpha into beta, right? So what is sum of roots from this? Alpha plus beta is minus b by a. So minus of minus b by a is x square coefficient, which is 1. So alpha plus beta is p. Let it be equation 1. And product of roots alpha into b is c by a, which is q by 1. Let it be equation 2. Now we need to find equation whose roots are these two values. Let's say given one root is a, let's assume it as a alpha into beta plus alpha plus beta one root. Let's assume another root as b, which is alpha beta minus beta. So we know alpha into beta from equation 2, which is q, and we know alpha plus beta from equation 1, which is p. So one root is q plus p, another root b will be alpha into beta. Again, from 1 and 2 we can write it as q, take minus common, which is alpha plus beta, value is p. So we got new roots for the equation. We need to find the equation whose roots are a and b now. So quadratic equation will be x square minus of a plus b sum of roots into x plus a into b product of roots equals to 0. We know the standard form. So substitute in this formula x square minus a plus b is q plus p plus q minus p it is into x plus a into b. What is a into b? Q plus p into q minus p. A plus b into a minus b, which is a square minus b square. So q square minus p square equals to 0. So here plus p minus p gets cancelled. So final equation will be x square minus 2qx plus q square minus p square equals to 0. So it is option x square minus 2x. So option A it is. Let's discuss question number 4. So alpha beta are roots of certain quadratic equation and gamma delta are roots of another quadratic equation. Okay. So first equation is x square plus ax minus b equals to 0. So roots are alpha and beta for this. So we can write relation between alpha and beta. So sum of roots is minus b by a, which is minus a. Product of roots is c by which is minus b. That these two equations are, let's name them as equation 1 and equation 2. There is one more equation given, x square plus ax plus b equals to 0, for which roots are gamma and delta. So sum of roots, which is gamma plus delta, is minus a. Gamma into delta is b. Let's name these two equations as number 3 and number 4. Now we need to find value of this expression. So expression is alpha minus gamma into alpha minus delta, beta minus delta into beta minus gamma it is. Let's multiply first two brackets here. Let's multiply these two brackets. We'll get alpha square minus alpha gamma minus gamma alpha plus gamma into delta. In the same way, multiply these two brackets. Beta square minus beta gamma minus delta beta plus delta into gamma it is. Now, here we can take minus alpha common. So alpha square. If you take minus alpha common, it will be delta plus gamma. Plus here gamma into delta it is. In the same way, we can take minus beta common here. Beta square. Take minus beta common. It will be gamma plus delta again plus here it is gamma into delta it is. So from equation 3 and 4, we can replace delta plus gamma, delta into gamma in both the brackets. Let's replace alpha square minus alpha into, so gamma plus delta is minus a plus gamma into delta is b. The same here, beta square. So gamma plus delta is minus a, minus to minus plus a beta plus b it is. So here also it will be alpha square plus alpha a plus b. If you observe options are in terms of b square. So now we got two brackets. Whose relation between them also we got alpha and beta. So what we can do is, yeah. So let's come to this. Alpha beta are roots of this equation, right? That means alpha and beta must satisfy these two equations, this equation. So substitute alpha, substitute beta in this equation. So I'm writing here. If you substitute alpha, we'll get alpha square plus a alpha equals to b. In the same way, if you substitute beta, we'll get beta square plus a beta equals to b, right? Now we can utilize these two results. So alpha square plus a alpha here. Alpha square plus a alpha can be replaced as b. So it will be b plus b into, here beta square plus a beta can also be replaced as b. So which is again b plus b. So b plus b, 2b into 2 betas, which is 4b square. Option B. Let's discuss question number 5. So omega is complex cube root of unity. Then we need to find value of this. So sine of omega power 10 plus omega power 23 into pi minus pi by 4. We need to find value of this expression. So we know omega power 3n is 1. Omega power 3n plus 1 multiples will be omega. Omega power 3n plus 2 will be omega square. We can utilize this results here. So 10 is 3n plus 1 multiple, right? So which will be omega? Sine of omega plus. And 23 is 3n plus 2 multiple. 3 times 21, 21 plus 2. So it will be omega square into pi minus pi by 4 it is. So omega plus omega square can be written as minus 1. So minus 1 into pi will be minus pi by 4. We can take out minus common. Sine of minus theta is minus sine theta. So it will be sine pi plus pi by 4. And how to simplify this? Pi plus pi by 4 falls in third quadrant where sine is positive, sine is negative, and axis angle is multiple of pi. Sine will be sine. So minus of minus sine pi by 4 it is. Minus into minus plus sine pi by 4 is 1 by root 2. The final answer is 1 by root 2. Let's discuss question number 6. So roots of the equation. So a quadratic equation is given. So are always either roots are real or distinct, real and equal, real and imaginary they are asking. So it is related to nature of the roots. To decide nature of the roots, we need to find discriminant, right? Which is b square minus 4ac. So let's apply this formula. What is b here? 2 times c minus a. Square of it will be 4 times c minus a whole square. Minus 4 times a is x square coefficient, which is b minus c, and into c, which is a minus b. So we can take 4 common. Expand c minus a whole square. So it will be c square plus a square minus 2ac. Multiply these two brackets. So we'll get a into b minus b square minus ac plus bc. Right. So 4 times a square plus c square. Multiply with minus sign here. Minus into minus, it will become plus b square. And here minus 2ac. Here minus ab plus ac and minus bc it is. So minus 2ac plus ac will be minus ac. So 4 times a square plus b square plus c square minus ab minus bc minus ac. So to decide nature of the roots, so the discriminant can be 0 or greater than 0 or less than 0 in all the possible cases. So to decide here equality sign or inequality sign, so we need to somehow simplify this. So 4 into, let's do one thing. Let's multiply 1 4 inside the bracket. Let's multiply 2 from this. 4 can be written as 2 into 2. So multiply with 2 will get 2a square. 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ac. Right? So is 2a square can be written as a square plus a square in the same way b square plus b square and c square plus c square. Utilize one a square, b square, and this minus 2ab. All together we can write as a minus b whole square. In the same way, we can use one leftover b square, c square, and 2bc. We can write all these three terms as b minus c whole square. So similarly, we'll be left with a minus c whole square part. Okay. Now we got sum of squares. Sum of squares will be greater than or equal to 0, greater than or equal to 0. What about b minus c case? See if you observe the question. In the question, b minus c is coefficient of x square. If it is quadratic equation, b minus c should not be 0. That means b can never be equals to c. That means this value will be always greater than 0. So this entire expression will never become 0, right? So this entire expression will be definitely greater than 0. That means discriminant greater than 0 we are getting. Which concludes roots are real and distinct. Option A it is. Let's discuss question number 7. So set of values of p for which 6 lies between the roots of the equation. So a quadratic equation is given x square plus 2 times p minus 3 into x plus 9 equals to 0. Okay. Now we need to find values of p for which 6 lie between the roots there. Okay. If roots are alpha and beta, so we know x square coefficient is 1 here. That means graph will be opening upwards. Let's say one root is alpha, another root is beta. So 6 should lie between alpha and beta, right? So it is related to location of roots, which it comes under third case in the case 3. So where x naught lies, x naught here it is 6, x naught lies between both the roots. So we have got condition for this. What is that condition? A into f of x naught should be less than 0. Let's apply this result. So what is A in this? A is x square coefficient, which is 1. And x naught is 6 in this case. So 1 into f of 6 should be less than 0. 1 into what is f of 6? Substitute x equals to 6 in the given quadratic equation. So 6 square, which is 36, plus 2 into p minus 3 into 6 plus 9 should be less than 0. So 36 plus 12 into p minus 3 plus 9 less than 0. 36 plus 12p minus 36 plus 9 less than 0. Plus 36 minus 36 gets cancelled. So 12p is less than minus 9. So p should be less than minus 3 by 4 it is. So that means p belongs to minus infinity comma minus 3 by 4 is option B. So no need to go for discriminant case in this. Just go through the theory once again. This location of root square. Let's discuss question number 8. The points ABC are in argand line or vertices of an equilateral triangle. The vertices of equilateral triangle are given A, B, C. Now we need to find Z value in this. That means somehow we need to generate some equation in terms of Z. So we have got direct result for this. If vertices of equilateral triangle are given, let's say Z1, Z2, Z3 are given, and if it is equilateral triangle, then the result is Z1 square plus Z2 square plus Z3 square will be equals to Z1 into Z2 plus Z2 into Z3 plus Z3 into Z1 it is. In our case, let's assume point A as Z1. So Z1 is Z, Z2 is minus Z, and Z3 is 1 minus Z it is. So let's substitute all these values in this equation. So Z1 square is Z square, Z2 square is minus Z whole square, which is again Z square, plus Z3 square is 1 minus Z whole square, and Z1 into Z2, Z into minus Z plus Z2 into Z3, which is minus Z into 1 minus Z plus Z3 into Z1, which is 1 minus Z into Z it is. Okay. So Z square plus Z square, it is 2Z square. Expand 1 minus Z whole square as well, which is plus 1 plus Z square minus 2Z equals to minus Z square, multiply these two brackets, minus Z plus Z square You multiply these two brackets here. So plus z minus z square. So plus z minus z gets cancelled in the same way z square and minus z square gets cancelled. We are left with 2z square plus z square, 3z square shifted to LHS. So we'll get 4z square minus 2z plus 1 equals to 0. So we are supposed to find z value. So we got one equation in terms of z, quadratic equation. So find roots for this. That will give us z value. So minus b, which is 2, plus or minus root over b square, which is 4, minus 4ac, 4 into 4 is 16, divided by 2a, 2 into 4 it is. So 2 plus or minus 4 minus 16, root over minus 12. Root over minus 12 can be written as 4 into minus 3. So which is 2 times root minus 3 can be written as root 3i divided by 2 into 4. 2 gets cancelled. So we'll be left with 1 by 4 into 1 plus or minus root 3i it is. So option C. Let's discuss question number 9. So sigma n equal to 0 to infinity 2i by 3 whole power n is given. Let's open the sigma. Substitute n value as 0. So 2i by 3 whole power 0 plus 2i by 3 whole power 1 plus 2i by 3 whole square. So on till you get infinite number of terms. So it is nothing but sum of infinite GP. So we have got formula for this for sum of infinite GP, which is a by 1 minus r. This is in case of G. So let's apply this formula. What is a in our case? Which is 1. 2i by 3 whole power 0 will be 1. So 1 by 1 minus r. What is r? Common ratio is 2i by 3. 2i by 3 is getting multiplied after every consecutive term. So 1 minus 2i by 3. So our value is 2i by 3 here. Let's simplify this. If you take LCM, they will come into numerator 3 by 3 minus 2i. We need to, what you are supposed to do? Multiply and divide with conjugate of denominator, which is 3 plus 2i by 3 plus 2i. It is. In numerator, multiply with 3. So 3 into 3, 9 plus 6i by denominator a plus b into a minus b, which is 3 square minus 4i square. So 9 plus 6i divided by 9 plus 4 it is. 9 plus 6i divided by 13 it is. So option. Let's discuss question number 10. So we need to find value of this determinant. So in two ways we can solve this. So if you observe determinant is dependent of in terms of alpha and beta, even options are also dependent of alpha and beta. You can go for substitution. Okay, you can substitute in this way that either alpha or beta you can substitute as 0. Substitute beta equal to 0 and expand determinant. So this you can consider it as method 1. So you try this. I'll discuss normal approach. Method 2, we can use row operations here. So what is given delta determinant here? It is cos alpha plus beta. Near minus sin alpha plus beta. Here cos 2 beta is. So if you observe here, what is cos alpha plus beta formula? Cos a plus b, which is cos a cos b minus sin a into sin b. So from row 2 we have got sin alpha. From row 3 we have got minus cos alpha. Right? So if you multiply row 2 with sin beta, you get sin alpha into sin beta. Here it is sin alpha into sin beta. If we multiply row 3 with cos beta, we'll get minus cos alpha into cos beta. Here it is plus cos alpha cos beta. Then if we add, we can generate 0 here. That means We need to apply this operation. R1 tends to R1 plus sine beta into R2 plus cos beta into R3. Okay. So if we apply this operation here, so here sine beta into sine alpha or row 2 element. We get plus sign here, we have got minus sign. And if you multiply cos beta with row 3 element, we'll get minus cos alpha into cos beta. Here we have got from row 1 element, which is plus cos alpha into cos beta. That means we'll get 0 here. The same way we'll get 0 even for A, row 1, column 2 element. Even the same way we'll get 0 here as well. So row 2 elements are sine alpha, cos alpha, and sine beta, and minus cos alpha, sine alpha, and minus cos beta. So all entire row 1 elements are 0, so that will be 0. Okay. So it is option B. Let's discuss question number 11. So system of linear equations are given, which has got infinite number of solutions. We know conditions for infinite number of solutions, which is delta equals to delta 1, delta 2, delta 3. All four delta values will be 0. Okay. So in this we need to find value of unknown A. Let's write all the linear equations first. 3x plus 2y plus z equals to 6. Second equation is 3x plus 4y plus 3z equals to 14. Third equation is 6x plus 10y plus 8z equals to A. So we need to find this unknown value A here. So I'm utilizing delta 1 equals to 0. So what is delta 1? So replace column and elements with constant terms, which is 6, 14, A, and two right column elements 2, 4, and 10. Coefficients of y terms and coefficients of z terms are 1, 3, and 8. So delta equals to 0. So before expanding data to find this unknown A, let's try to convert two values into zeros. Let's try to convert the 6 and 2 in 2 to zeros here. So it is column one element. So C1 tends to C1 minus 6 times 6 times C3. In the same way, C2 tends to C2 minus 2 times C3 it is. Okay. So by applying these two column operations, column one elements will become, so C1 minus 6 times C3. So 6 minus 6, 0. In the same way here, 2 minus 2, 0. Right? Column 3 elements as it is, 1, 3, and 8. Here you'll get 14 minus 18, which is minus 4. Next, A minus 48 here. In the same way here, minus 2, and we'll get minus 6. Right? Now let's expand across row 1, where we have got two zeros. So plus 1 into its minor, which is minus 4 into minus 6, 24. And minus of minus plus 2 times A minus 48 equals to 0 it is. Take 2 common overall, we'll get 2, 12 plus A minus 48 equals to 0. So A minus 36 equals to 0, where A equals to 36 is option D. Let's discuss question number 12. Given A is a non-singular matrix, that means that A is non-zero, which concludes A inverse will exist, right? Next, an equation is given in terms of A and I. So we need to find this expression value. So Let's write this expression once again. A minus 2i into a minus 4i equals to null matrix. It is given for us. So multiply these two brackets here. A into a square minus 4 times a into I, which is 4a. Here minus 2 times I into a is also a, plus minus 2 into minus 4 I will be plus 8 times I square, which is again I, equals to null matrix. So a square minus 6a plus 8i equals to null matrix. So we need a and a inverse in this expression. So we know a inverse will exist. So we can pre-multiply or post-multiply with a inverse to generate a inverse in this equation. Let's say I'm pre-multiply this entire equation by a inverse. Okay. We'll get a inverse into I'm writing this a square as a into a minus 6 times a inverse into a plus 8 times a inverse into I equals to a inverse into null matrix. So here a inverse into a can be written as I. So I into a minus again a inverse into a is I, we know. So 6 times I plus 8 times a inverse into I is a inverse, and a inverse into null matrix. It will be null matrix here. So we need a plus 1 by 6 times a plus 4 by 3 times a inverse here. So in LHS, we'll keep only a and a inverse. Let's shift this 6i to RHS. So we'll get I into a plus 8 times a inverse equals to 6 times I it is. So shift this 6 or divide it by 6, both the sides. I into a is a. So 1 by 6 times a plus 8 by 6 times a inverse equals to 6 into I by 6. 6 and 6 gets cancelled. 2 3s, 2 4s. So a by 6 plus 4 by 3 times a inverse equals to I it is. So it is the given expression a by 6 plus 4 by 3 A inverse, which is equals to I. So it is option A. Let's discuss question number 13. So a quadratic equation is given for which both roots of this equation are real and distinct, and they lie in this interval 1 and 5. Then m lies in the interval thereafter. So it is related to location of roots. So it is the case where both roots are between x1 and x2, right? So graph will be in this form. Let's say x1, x2 here. Both roots are between x1 and x2. So graph will be somewhat like this, right? Where both roots are between x1 and x2. So we know conditions for this. First condition is discriminant should be, so roots are real and distinct, they are saying. Definitely discriminant should be greater than 0. And vertex should be between x1 and x2. Vertex x coordinate should be between x1 and x2. And a into f of x1 is greater than 0. And a into f of x2 also should be greater than 0. In our case, why we have drawn opening upwards? Why? Because x square coefficient is 1 in this, where a is 1. So let's apply each condition one by one. So first discriminant should be greater than 0. So given quadratic equation is x square minus mx plus 4 equals to 0. So for this discriminant b square, which is m square minus 4ac, which is 16, greater than 0. So we can write as m plus 4 into m minus 4, which is greater than 0, right? That means let's plot on number line. Critical points are minus 4 and plus 4. So favorable region is positive region. So greater than 4, less than 4. Why? Because plus minus plus it will be. Next, let's apply second condition now. Vertex should be between x1 and x2. What is vertex? So vertex x coordinate will find by using this value minus b by 2a. This minus b by 2a for this minus of minus m. M by 2 into 1, which is 2, will be less than x1 less than x2. What are x1, x2 in our case? So interval is given as 1 comma 5, right? So x1 will be 1. In our case, x2 will be 5. So it will be less than 5, greater than 1. So m will be less than 10, greater than 2. So we have got one more condition for m. Let's apply third conditions as well. A into f of x1. So a is 1 here. So f of 1. So 1 into f of 1 should be greater than 0. So substitute 1 in the given quadratic equation, x equals to 1. So we'll get 1 minus m plus 4 should be greater than 0. That means m should be less than 5. In the same way, let's apply second condition. This a into f of x2. A into f of x2. What is x2 here? Which is 5. Even this should be greater than 0. A is again 1. So f of 5. Replace x value as 5 here. So 5 square 25. 5 square is 25 minus 5m plus 4 should be greater than 0. So 29 is greater than 5m. M should be less than 29 by 5. So we have got three different conditions for M. First case, second case, and third case. So M should satisfy all these three conditions, right? Then only our quadratic equation will satisfy the given conditions from the question. So we need to take intersection of first case, second case, and third case. Intersection of all the k values. So let's plot a number line. In the same plot, let's mark all these given conditions of k. So critical points are minus for from the first case minus 4 to plus 4. So k should m should be greater than 4, less than minus 4. Next, from second condition, m can be between 2 and 10. So 2 will be somewhere here, 10 let's say somewhere here. So m will be between 2 and 10. Both are not included. 2 is not included. Even 10 is also not included. Next, third condition, m is less than 5. Let's mark m less than 5. So let's say 5 is somewhere here. M less than 5 will be this case. Next, m less than 29 by 5. 29 by 5 is approximately 5.4 something. So less than 5.4. This is less than 5.4. Okay. So both 5 is not included. Even 5.4 is also not included. Now we need to take intersection of all these three conditions. So where do we get all the common lines? So here in this region, if you observe between 4 and 5, we are getting common region, right? For all the four lines. So 4 is not included in the first case. So it won't be included in other cases as well. So m belongs to least value will be 4 and maximum value will be here at 5. So 5 is not included. So even it won't be common in all the cases. M should lie between 4 and 5. It is option A. Let's discuss question number 14. So matrix A is given and matrix A is given. Then we need to conclude on this matrix A whether it is invertible or not. So a matrix is invertible if it is non-singular. That means del it should be non-zero value. Then matrix will be, if data is non-zero, then matrix will be invertible, right? Let's check whether given matrix is invertible or not. So we need to find its determinant. So find data of this. So data will be data of e power t, e power t, and here e power t, and here e power minus t into cos t minus e power minus t into cos t minus e power minus t into sin t, and here 2 times e power minus t into sin t, e power minus t into sin t minus e power minus t into sin t, e power minus t into cos t, and here minus 2 times e power minus t into cos t it is. So let's take, so we can take e power t common from column 1. The same way e power minus t from column 2, e power minus t from column 3. So we'll get e power t into e power minus t into e power minus t. This 1, 1, 1. And we'll be left with cos t in the column 2 here. And e power minus t is taken common. And even we can take minus common here. We'll get minus of cos t minus sin t. And here 2 times sin t it is. And the same one from column 3, if we take e power minus t common, we'll get sin t. And here minus sin t plus cos t, and here minus 2 times cos t it is. So outside, so e power t into e power minus t will be 1. So we'll be left with e power minus t here. Before expanding its determinant, so let's try to convert these two ones into zeros. So for which we need to apply r2 tends to r2 minus r1, and r3 tends to r3 minus r1. Let's apply these two row operations so that these two elements will become 0. Once we apply these two operations, we'll get 1 cos t and sin t here. So r2 minus r1, 1 minus 1, 0 it is. Next, r2 minus r1, subtraction of these two will give us minus sin t, minus sin t, minus 2 cos t, right? In the same way here, minus of these two values, we'll get minus 2 sin t, minus 2, minus 2 sin t, minus 2 sin t plus cos t it is. Next, 1 minus 1, 0, 2 sin t minus cos t, and here minus 2 cos t minus sin t it is. Now let's expand determinant here across column 1, e power minus t into, so multiplication of these two. So minus we can take common, minus into minus plus, it will be sin t plus 2 cos t whole square minus multiplication of these two. 2 sin minus cos minus 2 sin plus cos. Here we can take minus common, we'll get 2 sin minus cos here it is. So minus of minus plus, it will be 2 sin t minus cos t whole square. It is just determinant expansion here, which everyone can do. So expand these two brackets. So in this you'll get 2 cos square, 4 cos square theta. Here 4 sin square t you'll get. So after this expansion, we'll get 4 times sin square plus cos square, which is 4. And here sin square plus cos square, again it will be 1. Here plus 2ab part in this, minus 2ab part in this gets cancelled. So I'm directly writing here. So 4 times sin t into cos t. In this part, you'll get minus 4 sin t into cos t it is. So these two gets cancelled. So we'll get 5 times e power minus t. So this is the det A, right? So we know e power minus t. In this, t can be any real number. T can be any real number. And det A is non-zero, right? So T belongs to real number. So det A can never become zero, right? So if det is non-zero, then definitely given matrix A is invertible for any value of real number. So it is option D. Let's discuss question number 15. So let Z1, Z2 be two complex numbers. So two complex numbers are given, which will satisfy the following conditions. One is mod Z1 equals to 9 given. And another equation is Z2 minus of, we can take minus common, it will be 3 plus 4i equals to 4. We know Z minus Z not equals to R represents a circle, represents circle whose center is Z naught and radius is R, right? So in the same way here, for this circle, center is, let's say C1, center will be origin and radius R1 is 9, right? For circle 2, center is 3 comma 4 and radius is 4 here, okay? So both are circle equations. We need to find minimum value of Z1 minus Z2. We can easily plot circle 1. Circle 1, center is origin, radius is 9, right? So circle center is origin and radius is 9. It will be 9 comma 0, 0 comma 9. So this is circle. So on this Z1 will be any point on this. Okay. So locus of all this Z1 will be the circle. In the same way, for circle to center is 3 comma 4. So 3 comma 4 will be somewhere here inside this circle. Somewhere inside this circle, right? 3 comma 4. And radius is given as 4 units. So this is 4 here. Definitely our circle will touch this x coordinate, x axis. But we don't know whether it will cut the circle 1 or circle 1 or not. So how to decide that? We know relative position conditions for relative position of circles. So for which we are supposed to find distance between centers. C1, C2 is root over 3 square plus 4 square, which is 5. And if you observe R1 minus R2, what is mod R1 minus R2, which is 9 minus 4, it is 5. So we are getting C1, C2 equals to mod of R1 minus R2. So this is the condition we'll get if two circles are touching internally, right? So that means our circle 2 will be touching circle 1 internally here. Okay, so it is 4 here. So radius is also 4. Definitely it will, x-axis will be tangent. This length is 3. So our circle will cut y-axis and it will touch circle C1 in this way, right? So we need to find minimum value of Z1 minus Z2. It is distance between 2 points. See, Z1 is any point on circle 1. Z2 is any point on circle 2 here. This is Z2. So pick any red color point. Pick any red color point on the circle 1. Pick any yellow color point on circle 2. The distance between them should be minimum. So that minimum distance points will be common points for both of them. So which will be this point, which is common for both of them. So distance between them will be definitely 0. Distance between So Z1, Z2 minimum value will be definitely 0. Why? Because circles are touching internally. There will be common point. We can consider those common points here. So minimum distance will be 0. Hence option C. Let's discuss question number 16. So if a matrix A is of order 3, order of matrix A is given as 3, n value is 3, and det A is given as 5, and B is defined as adjoint A, then we need to find value of this expression, which is det of A inverse into AB whole transpose, right? So we have got properties. What is det of A inverse? It is 1 by det A, and AB whole transpose can be written as B transpose into A transpose. Or let's do one thing. So that is scalar value inside. So to take out scalar value from inside determinant, we have got property det of Ka will be A power n times det A. So det of A inverse is 1 by det A. So it comes out as 1 by det A whole power 3. N value is 3, right? So into det AB whole transpose. You know that of A transpose equals to det A. So that of AB whole transpose will be equals to that of A into B. And that A value is 5. Let's substitute here 1 by 5 whole cube into this will be nothing but that of AB. So that of A into B is that A into that B. So 1 by 5 cube into that A into that B, right? So B is nothing but adjoint A. That of B can be written as that of adjoint A. So 1 by 5 cube into det A is 5. Det of adjoint A is det A, which is 5, whole power n minus 1, which is 3 minus 1, 2. So 5 cube and 5 cube gets cancelled. So final answer will be 1. It is option B. Let's discuss question number 17. This matrix P, matrix Q is given. So we need to find det of this expression. Okay. So in this expression, if you observe, we have got P square, PQ, P power 4, Q square, Q power 4. So I just solve for P square here. P into P, if you do, you're getting again matrix P here, right? You know how to multiply two matrices, multiply row 1, column 1, you'll get this element. Same row 1, column 2, you'll get this element. Next row 1, column 3, you get this element. Same process you repeat for row 2 and row 3 as well. Okay. So we got here P square as P square is P. So P equals to P square. What about PQ? Even PQ also will be P. Even P power 4, P power 5, all these values will be P itself, right? Next. We got Q square, Q power 4 as well in the expression. So I just found Q square. So Q square value I'm getting it as I. So if Q square is I, Q square is I, even Q power Q cube also will be Q power 4. Okay, we got Q power 4 here if you observe. So Q power 4 will be again even powers of Q. Q power 4, Q power 6, Q power 8. All this will be unit matrices. Okay. So we need to find that of P plus P square Q square plus P cube plus P power 4 Q power 4 so on 1000 times. So wherever we find P square P cube, here it is P. We can replace P square as P, Q square as I. P into I will be again P. We get P cube is also P. And again P power 4 is P, Q power 4 is I. So this will get how many times P? 1000 times. So we'll get that of 1000 P it is. So which is nothing but 1000 times whole cube. You can write, you can take it outside of determinant. 1000 cube into det P. So now just we need to solve for det P here. So what is det P? So let's find determinant of P. This is matrix P, right? Let's expand across row 1. So that P will be plus 2 into its minus 9 plus 8. It's minus of minus plus 2 into 3 minus 4. It's minus 4 into 2 minus 3, which is minus 1. So minus 1 into minus 2 minus 1 into 2 is minus 2 plus 4. So we got that P value as 0. If that P is 0, this entire value will become 0 here. So this entire that value will be 0. See, in our case, in this, another approach will be, even we can avoid finding this P square part and Q square part. In this expression, directly we can take P common. Directly we can take P common, right? So we'll get P common here. Find just det of P. If you find det of P, it is coming out to be 0. So det of P into any value will be 0. This is option D. Let's discuss question number 18. So matrix A given, matrix B given, some matrix C is also given for us. Then the value of sum of this expression they're asking. Trace of A plus trace of A into BC by 2. Trace of A into BC by 4. So in each term, if you observe B into C is present. So let's find A into C matrix first. So matrix B from question it is 3, 4, 2, 1, 3. And matrix C is 3 minus 4 minus 2 and 3. Let's multiply these two. So you know how to multiply. So row 1 will multiply with column 1. You get it as 9 minus 8, which is 1. Next row 1 with column 2. Minus 12 plus 12, which is 0. Next, same thing will repeat with row 2. Row 2 and column 1. 6 minus 6, which is 0. Row 2 with column 2. Minus 8 plus 9, which is 1. So we got B into C as identity matrix here. So in each expression, A into BC is present. Now A into BC will be A into I, so which will be matrix A itself, right? Now let's come to the question. They're asking us to find trace of A plus A into BC can be written as A again. So trace of A by 2. Next A into BC again can be written as A plus trace of A by 4 and so on till infinite number of terms. So from the question trace of A is 2 plus 1. Trace of A is 2 plus 1, which is 3. So trace of A is 3. What will be trace of A by 2? So A by 2 is nothing but 1 by 2 into A. So every element of A gets multiplied with 1 by 2. In the same way here, even diagonal elements also gets multiplied with 1 by 2. That means in trace of A by 2, so you get 2 by 2 plus 1 by 2, which is again, you can write as 1 by 2 into trace of A, here it is. This can be written as 1 by 4 into trace of A, so on, infinite number of terms. So 3 plus 1 by 2 into trace of A is 3 plus 3 by 4 and so on till infinite number of terms. We can take 3 common. We'll get 1 plus 1 by 2 power 1 plus 1 by 2 square. Next 1 by 2 cube, so on, infinite number of terms. So we got infinite GP here. We know formula for it. So sum of infinite GP is A by 1 minus R it is. Let's apply this formula here. A is 1. So 1 by 1 minus R. Common ratio is 1 by 2. 1 by 2 is getting multiplied if you observe here. So 1 minus 1 by 2 it is. So if you take LCM, you will get 3 into 2 by 2 minus 1, which is 1. So 3 into 2 is 6. The final answer is 6 for this. Let's discuss question number 19. So f of x is defined as det of this expression, det of this. We need to find f of 11 here. So let's try to find f of x function, for which we need to solve this determinant. So if we observe this det, From row 2, we can take x common. X is common from row 2. From row 3, x into x minus 1 is common. So take x common from row 2 and x into x minus 1 from row 3. Then leftover elements will be 1, x plus 1 in row 1. From row 2, it is 2, x minus 1 and x plus 1. Why? Because x is taken common here. From row 3, x into x minus 1 is taken common. So here leftover element will be 3, and here x minus 2, and here x plus. So if we observe again from column 3, we can take x plus 1 common. So we'll get x into x will be x square here, and x minus 1, and x plus 1 is taken common from column 3. So leftover elements will be 1, 2, 3, x, x minus 1, x minus 2, 1, 1, 1 it is. So instead of directly expanding, let's convert these two ones into zeros, for which we are supposed to apply these two operations. R2 tends to R2 minus R1, and R3 tends to R3 minus R1. So outside it is x square into x square minus 1 a plus b into a minus b. Here 1 x, we are not applying any operation row 1, right elements as it is. On row 2 we are applying R2 minus R1. So 2 minus 1 1, x minus of minus x will be minus 1, 1 minus 1 0, R3 minus 1, R3 minus R1, 3 minus 1 is 2, next x minus 2 minus x minus 2, 1 minus 1 0 it is. Now expand this data across column 3, x square into x square minus 1. So if we expand across column 3, it will be plus 1 into its minor, which is minus 2 plus 2. Minus 2 plus 2 gets cancelled, which is 0. So x square into x square minus 1 into 0. 0 into anything is 0. That means f of x is 0. We got. So even f of 11 also will be 0. So f of 11 will be 0. So it is option A. Let's discuss question number 20. So matrix P given, matrix A given. So Q is defined in this form PA into P transpose. And some equation is given. P transpose it to Q for 2007 to P. This is one matrix, 2 cross 2 matrix, in which elements are A, B, C, D. We need to find this expression value, which is dependent on A, B, C, and D values. Okay. So if you observe matrix P, it is orthogonal. So how we are deciding it is orthogonal matrix? In orthogonal matrix, sum of products of any row elements or any column elements will be 1. What I said, sum of products of any row elements or any column element should be 1. Why? Because row elements or column elements will be components of unit vector. So if you observe here, root 3 by 2 whole square will be 3 by 4. If you consider column 1, minus 1 by 2 whole square is 1 by 4. So magnitude wise it is 1. So it is applicable for any row. And even dot product of any two row elements or any two column elements will be 0. Okay. This will conclude it is orthogonal matrix. Or else we can apply this condition as well. So condition for orthogonal matrix is P transpose into P should be equals to I, right? So what is P transpose here? Root 3 by 2, 1 by 2. And here minus 1 by 2, root 3 by 2 it is. Multiply with P, which is root 3 by 2, 1 by 2, minus 1 by 2 into root 3 by 2 it is. So multiply row 1 with column 1, root 3 by 2 into root 3 by 2, 3 by 4 plus 1 by 4. Next here root 3 by 2 into plus 1 by 2, minus 1 by 2 into root 3 by 2 will be 0. Next here 1 by 2 into root 3 by 2, root 3 by 2 into minus 1 by 2. Again it will be 0. Here it is 1 by 4 plus 3 by 4 it is. So which is a unit vector. It's 1 0 0 1. So P transpose into P transpose into P, we are getting it as unit matrix. Hence we can conclude it is matrix P is orthogonal, right? Okay. We need to find this expression here. P transpose into Q power 2007 into P it is. So P transpose into Q power 2007 can be written as Q into so on 2007 times into P. So Q is defined as PA P transpose, right? So substitute here, it will be PA P transpose into PA P transpose so on. How many times will write? 2007 brackets will get into P will be there. So we know P transpose into P is I. So all this P into P transposes will be I in each bracket. So in each bracket, A will be left, right? I into A, I into A. So how many A's you will get? So it is nothing but number of brackets. So number of Q's will be 2007. So how many times you'll get A here? 2007 times you'll get A here. A into I will be an A of A. So we'll get A power 2007 here. So we need to solve for A power 2007. Okay, matrix A is given from the question. It has 1, 1, 0, 1. Let's try to observe pattern here. Let's find A square. So for finding A square, we need to multiply with one more matrix A. So if you multiply these two, we'll get 1 into 1, 1 into 0. So 1, next 1 plus 1, 2, next 0, next row 2 with column 2, which is 1. This is A square matrix. And A cube matrix will be, again we need to multiply with one more matrix. So A cube will be again 1, next 1 plus 2, 3, next 0, and 1 again. So what is the pattern that we are observing? So if we observe 1, 0, 1 is common. In A, even in A square 1, 0, 1 is common. Even in A cube 1, 0, 1 is common. In A power 1 we got 1. In A power 2 we got 2. In A cube we got 3. So from this we can conclude in A power 2007 we'll get 1, 2, 0, 0, 7, 0, and 1. Okay, so this is A power 2007. A power 2007 is 1, 2, 0, 0, 7, 0, and 1. So it is given as ABCD. That means from here, A value is 1, B value is 2007, C is 0, and D is 1. Now we need to find this expression value. So 2 into A, which is 2. 2 into A is 2 plus B is 2007 minus 3C, which is 0, minus 4D minus 4. So 2007 minus 4, 2007 plus 2 minus 4 is minus 2. So it will be 2005. So 2005 is final answer. Let's discuss question number 21. So I square value given. So sigma of this, sigma of n equals to 1 to 200 I power n we are supposed to find. Let's open the sigma. Substitute n value as 1 first. It is I power 1 plus I square plus I cube so on I power 200 it is. The sum of finite GP. What is sum of finite GP formula? It is A into 1 minus R power n by 1 minus R. So in our case, A is I first term, 1 minus common ratio is R. So A is I, common ratio R is also I. So number of terms are 200. So I into 1 minus I power 200 divided by 1 minus R, which is I again. So what is I power 200? I power 200 can be written as I square whole power 100. I square is minus 1 whole power 100 is 1. So I into 1 minus 1 by 1 minus 1. So 1 minus 1 is 0. So 0 by anything will be 0. Final answer is 0. Let's discuss question number 22. The square matrix P satisfies this equation. So equation is P square equals to I minus P. Let it be equation 1. Whereas I is identity matrix phi and P power n is defined as P power n. For certain value of n, we are getting phi I minus IP. Then what is this n value they are asking? Okay. So P square we know. How do we calculate? PQ. So multiply with P on both sides here. So pre multiply, unique and post multiply. So pre multiply with P on both sides. You get P into P square equals to P into I minus P square it is. So P into P square is P cube. P cube is P minus P square. P square again from equation 1, we can write it as I minus P. So it is P minus I plus P. So P cube is 2P minus I, right? So for P square we got minus P. For P cube case, for P coefficient is positive. In our case, coefficient of P is negative, right? So that means definitely for even power we'll be getting negative coefficient of P. So next even power is P power 4. Let's check for P power 4. Again pre-multiply with P. So we get P power 4 equals to 2P square minus P it is. Okay. What I did here, I just pre-multiplied with P again. So P into I is P. So 2 into P square is from equation 1. Again it is I minus P here. So 2I minus 2P minus P, which is minus 3P it is. So P power 4 we got 2I minus 3P, but it is 5I minus 8P in the question. So what is next even power after 4? It is P power 6. So how do we calculate P power 6? P power 6 we can write it as P power 4 into P square. So it be equation 2. From equation 2 and equation 1, P power 4 is 2I minus 3P. P square is I minus P. Multiply these two brackets, 2I into I, 2I square, which is again 2I. 2I into P is 2P. 2I into P is 2P it is. Next minus 3P into I minus 3P. Minus 3P into minus P plus 3P square. So 2I minus 5P plus again P square from equation 1. We can write it as I minus P from equation 1. If you simplify this, 2I minus 5P plus 3I minus 3P will get. So 2I plus 3I, 5I minus 5P minus 3P minus 8P. This is P power 6. So for power 6, we are getting 5Pi minus 5I minus 8P, which is required in the question. So what is n value from this? N is 6. So n value is 6 for this. Let's discuss question number 23. It is given 2 and I are roots of the equation. So equation of degree 4 is given, for which roots are 2 and I. Then we need to find value of minus 2a. Okay. A is coefficient of z cube in this. So given equation is 2z power 4 plus az cube plus bz square plus cz plus 3 equals to 0. For which roots are given as 2 and I. We know its degree is 4. So there will be 4 roots, in which one root is complex number. See, we know complex roots will always exist in conjugate pairs. So if one root is I, its conjugate also will be one of the root, which is minus I. Okay, let's consider one more root as alpha. Okay, so these are the 4 roots. So let's try to find this alpha value. So in the given equation, constant term is given, and even z power 4 coefficient is also known for us. So we can use product of roots formula. So let's multiply all the roots here, which is 2 into I into minus I into alpha. So product of roots is, so E by A from the given equation, which is 3 by 2. So 2 alpha into I square is minus 1 minus 2 minus plus it will be, which is 3 by 2. So alpha will be 3 by 4. We got alpha value as 3 by 4 now. We got all the 4 roots. Now we need to find A value. A is coefficient of Z cube. Now we can make use of sum of roots here to find this unknown value A. So sum of roots is 2 plus I plus minus I plus alpha, which is 3 by 4. So sum of roots will be minus B by A. So minus of A by 2 it is, right? I minus I gets cancelled. So take LCM here, 4 into 2, 8, 8 plus 3, 11 by 4 equals to minus A by 2, 2 ones, 2 twos. So from here, minus 2A will be equals to 11. This is what they're asking in the question, minus 2A value. So minus 2A value is 11. Let's discuss question number 24. So one root of quadratic equation is x square plus bx plus c equals to 0. So one root is given as 3 minus 4i, so which is a complex number. We know complex roots exist in conjugate pairs. So if one root is 3 minus 4i, so conjugate of this will be other root. Its conjugate will be 3 plus 4i. So let it be alpha, let it be beta. So we got roots of this quadratic equation, both alpha and beta. So let's write its equation now. So its equation will be x square minus of alpha plus beta into x plus alpha into beta equals to 0, right? So we need to find alpha plus beta, sum of roots, which is 3 minus 4i plus 3 plus 4i. So alpha plus beta is 6. Product of roots alpha into beta. Alpha into beta will be 3 minus 4i into 3 plus 4i. A plus b into a minus b. A square minus b square. So 3 square minus 4 square I square it is, which is 9. I square is minus 1. Minus into minus plus 9 plus 16 it is. So alpha into beta is 25. So our quadratic equation will be, let's substitute in this, x square minus alpha plus beta is 6. X square minus 6x plus alpha into beta is 25. So this should be the quadratic equation for these roots alpha and beta. So let's compare with the given equation, ax square plus bx plus c equals to 0. Okay, so a will be 1 and b is minus 6 and c is 25. A plus b plus c we are supposed to report, which is 1 minus 6 plus 25. Minus 5 plus 25, which is 20. A plus b plus c value is 20. Let's discuss question number 25. So a square matrix of order 3 and value is 3 and det A is given as minus 2. So we need to find det of this. So given expression is det of 3 times adjoint of minus 6 times adjoint of 3 A it is. We need to find det of this. This is given as 2 power m plus n into 3 power m into n. So we need to report here m plus n. That means power of 2 we are supposed to find. Okay. So we know two basic properties of adjoint. So adjoint of Ka is, so This k comes out of adjoint as k power n minus 1 times adjoint A, and det of k is, so from that k comes out as k power n times det A, where n is order here. Here k comes out as n minus 1 times, here n times. Just remember these two cases. Then we need to count number of steps. So 3 comes from det as, 3 comes from determinant in single step. It will be 3 whole cube, 3 power n times. So which is 3 cube. And let's see. Minus 6 comes out as first from adjoint one step and again from determinant second step. So in two steps it comes out from determinant. So first it comes out from adjoint, right? So it comes as minus 6 whole square from determinant whole cube. Next, let's take out this 3. First from adjoint, then again from adjoint, then from determinant. In 3 steps it comes out from enter this determinant. So first from adjoint, right? So it comes as 3 power n minus 1. So 3 square, and again from adjoint, again one more square, again from det. So whole cube. Right, remaining leftover terms now. So det of adjoint of adjoint of A it is. Okay, so from determinant we have removed all the scalar values present inside. So it is 3 cube into minus 6 whole power 2 into 3, which is 6 into a power m whole power n formula we can use here. 2 into 2, 4, 4 into 3, 12. So it will be 3 power 12. So we know formula for this, det of adjoint, which is det A whole power n minus 1 whole square. It is why, because we got two adjoints. N is 3, 3 minus 1, 2. So it will be 2 square here. Okay. So in RHS we need to write in terms of power of 2 and 3. So it is 3 cube and 3 power 12, which is 3 power 15. And here minus 1 power 6 will be plus. And 6 can be written as 2 into 3, which is 2 power 6 into 3 power 6 into that A value is given as minus 2. Let's substitute here, it will be minus 2 whole power 4 it is. So now 2 power 6 plus 4, which is 10, and 3 power 15 plus 6, which is 21. So we need to report m plus n value, which is power of 2. What is power of 2 here? 10. So m plus n value will be equals to 10 here. The final answer is 10.